Hello everyone, welcome to my presentation video. In recent years, with the rapidly industrial development, human discharge huge amount of nitrogen compounds into water environment. Unfortunately, the nitrogen brings serious problems to the water environment, such as water eutrophication, harm to human and aquatic animals, and also increase the cost of wastewater treatment. Therefore, the nitrogen removal of wastewater has been an area of immense concern all of the time. In the traditional biological denitrification process, through the nitrification, nitrogen is transformed into the nitrate nitrogen. The nitrate nitrogen is reduced to nitrogen gas by denitrification using organic matter as an electrical donor, and then achieve the purpose of removing the nitrogen from the sewage. Because of the different physiological properties, the denitrification process, which is established according to the traditional biological denitrification theory, is usually divided into aerobic and antioxidant two sections. Nitrification and denitrification cannot be done in the same space. The theory of heterotrophic denitrification originates comes from heterotrophic nitrification. Through the heterotrophic nitrification and aerobic denitrification, heterotrophic bacteria can convert ammonia nitrogen into gaseous products to achieve the nitrogen removal. Therefore, Shaw and other people named this type of heterotrophic nitrification of the strain as heterotrophic nitrifying bacteria. Compared with the traditional biological denitrification technology, the heterotrophic nitrogen removal technology has the advantage of saving the cost of sewage treatment, and it can also realize simultaneous removal of organic carbon and nitrogen under aerobic condition, which is of great significance to development of the new water treatment process. Nowadays, the research on the denitrification performance, mechanism, and application of heterotrophic bacteria is still at the initial stage. Studying the denitrification performance and new denitrification strains is important for improve the efficiency of denitrification, reducing the nitrogen pollution in the water environment and discharge to the wastewater. And most of the research is still staying in the laboratory scale of the small test stage. Most of the pure bacteria are used into artificial water distribution mechanism. The content of this study is in the open system under the constant current reactor pair denitrification capacity of heterotrophic nitrogen and aerobic denitrification ability. Therefore, this subject has novel academic research value and broad practical value, which can provide reference for the development of efficient biological nitrogen removal process. So the purpose of this study is using the heterotrophic denitrification strain NRD as a research object, establishing a continuous flow reactor and setting different hydraulic rotation time and carbon nitrogen ratio. Biomass, ammonia, total nitrogen, total organic carbon indicators continue monitoring. Inspection of the reactor ability of remove nitrogen and carbon. So in order to investigate the ability of NRD to treat a nitrogen-containing wastewater in a long term, the continuous flow rate will be built up, shown in this picture. The inside of the reactor is equipped with an overflow port at the top of the reactor, so that the volume inside the reactor is kept constant. And in order to keep the inside of the reactor with sufficient oxygen, the reactor is equipped with 4 aeration ports at the bottom of the reactor. And the reactor is equipped with a machine strainer to prevent the precipitation inside the reactor to ensure its uniform mixing state. And in order to ensure the stream NRD can work at the best temperature, the water bath temperature is maintained at 30 degrees. By means of a heating rod and a water pump is provided in the water bath device to ensure uniformity of the water bath temperature. And the concentration of ammonia nitrogen in the experimental reactor was maintained at 80 mg per liter. The experiment was divided into 2 stages according to the 2 different carbon and nitrogen ratio, and then according to the different hydraulic rotation time will be subdivided into 2 stages of each stage. Every day I will collect about 50 milliliter water sample from the reactor. A small amount of the water sample is detected using a spectrophotometer at a waves of 600 nanometer, and the remaining water sample was certified using a centrifuge, and the submetant after certification taken detecting the ammonia nitrogen, total nitrogen, total organic carbon, and other indicators. After that, I can achieve this study purpose. Thank you, everyone.